In this video, we're going to see how we can do a hypothesis test using Desmos. The first one that we're going to do is a hypothesis test for a population proportion. And so we're going to come right over here and we're going to select inference again. So remember, click the plus. That allows me to enter various things here. I want an inference and it's a proportion. So I'm going to do a z-test for proportions. The first information that it wants is the number of successes. And that's the information that we have here. So we're given n is 250. That's our sample size. X equals 124. That's the number of successes that I got. So here, I'm going to put 124, my successes, and here 250, my sample size. That creates the test. And now we don't want a confidence interval. We want a hypothesis test. So we're going to click that. And then we have to give it some information. We have to tell it what our null hypothesis is, and then we have to tell it whether it's a left-tailed, right-tailed, or two-tailed test. And for this one, let's see, our null hypothesis is that the proportion is 0.6. So I'm going to just click there, p equals, and type in 0.6. The research hypothesis is that p is less than 0.6. That's going to be my left-tailed test. So I'm just going to select left. And then you can see that it returns the p-value for me. And the p-value is 0.0004. I wanted alpha significance level of 0.01. So since the p-value is less than alpha, I can reject the null hypothesis. If I wanted to use the classical approach, I'm just going to look at the z-value that's returned here. And so you can see that I have a z-value of -3.357. So I can just pull up the normal distribution. And then I can tell it that I want to use the standard normal. Click on this arrow, tell it that I want cumulative probability. And now this time I want to see what the critical z-value is. So I'm going to have to tell it that I want bounds. And again, I want the left bound. And I want the area over here to the left that aligns with my alpha, 0.01. So 0.01. And you can see that the critical value is -2.326, which is to the right of my test statistic. So this agrees with the same conclusion that I had before. The p-value is obviously easier, but if you do need to use the critical value and the test statistic, this is how you do it. We can do this same procedure with a population mean. That's an example from 10.3. So let's take a look at this one. I'm testing the hypothesis that the mean is 4.5 versus the research hypothesis that it's greater than 4.5. So for this one, again, click on your add item plus button here, select inference, and then for a population mean, I need a t-test. I can either give it data or statistics. Here you can see that I have a sample mean and standard deviation. So I'm going to select statistics. And then I need to tell it my sample size, which is 13. My sample mean, which it tells me is 4.9. And my standard deviation, which is 1.3. Then I create the test. And again, I'm doing a hypothesis test. So I'm going to select this one here. I give it my null hypothesis, which I see over here is that the mean is 4.5. So I'm just going to type 4.5 there. This is going to be a right-tailed test because I'm testing the hypothesis that the mean is greater than 4.5. So I'm going to click and it shows me what I have over here. And you can see that it returns a p-value of 0.144. We wanted alpha of 0.1. So we would not be able to reject the null hypothesis because our p-value is not less than alpha. I hope this helps with your hypothesis tests. If you have any questions, please reach out to either me or your instructor, and you can reach me at jane.keller@joyce.edu. Thanks for watching.